Hello, this is Shravan. This is my video report for assignment 7 of GAM 470. So let's jump right into it. This is part 1. So this is using this is graphics objects using textures, and this thing should build like right about now. I don't know why it takes so much time the first time. Come on, come on. So wow, really did not expect that. Anyway. So here we go. We have two graphics objects here, and you can see we have two different textures, the crate and the dice. So let's get right to it. So here's the header file, and we have a reference to our texture. The type is going to be a shader texture, which is way back from assignment 4, I think. And basically, we have a method that sets the texture, and then in the render, what we do is we attach the texture to the shader, and then we just simply send over the world data and render to context. So this is just a note for myself. So in the DX app over here, we're basically just creating the graphics object, setting the textures to both of them, setting the worlds, and then you set the shader to context, and you're done. So that's that. Here's the second one, and this is color plus lighting, and basically it's pretty more or less the same, but we have a private struct here to store the material because that's what's going to vary per model. The type of shader is a shader color light, and so pretty simple. We have a set material over here, and basically the render in this case is just so the material is over here, and the render is just going to send the world material using our shader and then just render it accordingly. And I have no idea why this is taking so long, but still, there you go. So now we have two objects here, and this time these are their respective materials. So you can see on this red one here that we can see the light sort of glowing by as it as it passes by, and yeah, so there's light over there, and you can see that faint little spotlight on the green as well. So that's that. And finally, we have the third one, which was basically combining the first two, so it's texture and light, and it's really, again, it's just just the same thing. So you store your texture, you store your materials. We have the start going here again. You have a set material and a set texture, and then finally when we try to render it, basically you send the material, you attach the texture, and then you render the models. So that's really pretty straightforward. I need to do something about this. No clue why it's taking so much time to load. Any time now. Come on. Alright, so exact same thing. You have your crate and the dice, but you can see that now the crate and the dice, they have textures, but they're also being lit up. So yeah, nothing really remarkable there. But and in the DX app, again, pretty much the same setup, the two textures, the models. So you set the textures, you set the materials, and just set the world matrices, and well, you're sort of done. So yeah, that was pretty straightforward. The part 4 was meshes, so doing everything that we've done earlier, but on a per mesh basis. And I'll just show you the texture light and color light. Basically, it's pretty simple. You set the material, you can set either one material for all the meshes, or you can set it for a specific mesh. And it's the same thing with the textures. You either set it, either for the whole thing or for a particular mesh. And then when we render it, what we do is that we attach the texture. Now you've got a particular texture, so you cycle through all the meshes and attach the appropriate textures, and you send the world and material, and you're sort of done. So you're rendering per mesh according to what it is. It's again pretty simple for the color too. The only reason I'm showing both of them is because the scene, when it loads, is going to have both of them. And I think we're here. Awesome. So you can see very clearly that for the cottage here, we have two textures, and we have lighting as well. So we can see that this mesh is being rendered by the dice texture, and this thing, the base of the cottage, is being rendered by the crate face. Everything else, in fact, is being rendered by the crate face, but you can see that they're both lit pretty nicely. And then this is for the color light. So this is obviously I didn't really realize how big this thing is. I should probably have scaled it down, but you can see that it's being lit up pretty nicely as well. So that's again pretty simple. Now this last problem, oh my god, this was again pretty interesting. Just I tried two approaches here. For the first one, what I did was I tried to subclass. I tried to make the shader texture light derived from the shader texture, and the shader color light derived from the shader color, and to sort of have like the shader texture pointer in the graphics object, which could also handle shader texture light if possible. It seemed like a nice idea, but it was horrible to implement. So what I did in the end was I went for virtual functions in the shader base, because the biggest problem that we have right now is that all the shaders have their own sort of different weird way of sending model data. So what I did was that I sort of made pure virtual functions here to send the model data and the camera matrices. One sec. Okay. So if we take a look over here, what's happening here is that the roof, which is one particular mesh, is being rendered by the shader texture. So you can see that there is no lighting here. But for the other one, the base and that little chimney and everything, lighting is actually taking place. So there are two different shaders. And I can sort of demonstrate this by switching. So if I change the first one to be rendered by the shader texture and everything else by the other one, you'll see a different pattern. But anyway, meanwhile, so we want each shader to be able to send model data and cam matrices. These functions are pure virtuals. Setting a texture resource and sample or light parameters are optional, so they have just a default behavior where they do nothing, and in the corresponding classes we can actually implement them. Now if you see, the lighting is being done on this guy here or on every guy here, but the first mesh is not being affected by lighting. So that's how we rendered two different shaders. Anyway, so this is how we did it in the shader base, just making a bunch of virtual functions. It's the SE456 effect over here. And this is how you can sort of override it based on what the shader is. So we specified all the arguments, but really we don't obviously have to use them because it'll vary per shader. So here we don't really care about the ambient, diffuse, or specular, but the same thing here we would. So, but it sort of gets easier because now in our graphics object texture light, we can just hold an array of shader bases, and our render also changes. So we pass in the context, we pass in the view and projection matrices and the eye position if needed. And what we do here is now you can just bind the model to the context, and now based on what type of shader you have, you can call all the methods, and it's based on what type of shader it is, it'll do the appropriate things or it won't do anything. So that's how that's working here. Just a small disclaimer, I didn't, this was just to get like a proof of concept. I did it for the shader texture and shader texture light. I could do it for the color one also, but I think I ran out a little bit of time. But anyway, so I think that's it. I think I covered everything. Thank you so much for watching, and until next time, bye bye.